Alright, so, yesterday,
Interceptions.
if you remember, we finished all this stuff. I did this in first period. I did all this with you all on Friday.
I wasn't here Friday.
Well, so bad.
You weren't here yesterday.
My bus ran super early.
It's okay, I can vouch
Are you
for
going to show
that.
us how to solve that problem? Because
That's exactly what I'm going to do.
Because that
We
made
just
me
need
so
a few more
mad.
minutes.
So, we took time.
Which one of y'all had your paper?
About 3.5 years.
Yesterday, and I gave you a problem, and I asked you to solve it. I even let you work together in your groups.
Oh, yeah.
The paper came in yesterday.
The question of all questions is what is the cost of an atom of aluminum? For that, I gave you a sheet.
Honestly, I'd say it's at most $1.
How small of an atom?
Very small.
Okay,
I'd say at
very
least
small.
smaller than my pointer finger.
Well, yes, this is true. Extremely small. So you're saying that an atom costs $1,
I'm
and
saying
the whole roll almost cost me $3.
I'm
So
saying
there's
at
3
most-
atoms.
I'm saying at most $2 or
I'm
$1.
going to have to write this
At
down.
most.
Okay, if you want to. This is the fun part of this. You can figure out how to do it. All right, so we get the sheet, then we have the roll.
Money's a stupid concept anyway. It could cost like $1 million if no one would bet or not, as long as other economy changes.
Well, if it cost $1 million, I wouldn't have it.
Yeah, but I mean, like, if everything else changes, we can probably be like, oh yeah, just $1 million.
Zimbabwe kind of
Sorry.
inflation.
That's funny. All right, so here's the information I gave you. So here's the thing with this problem, and what I like, the reason I gave this to you. This is all about teaching you to think critically. And it's important for you to learn how to think critically. Not just if you're ever going to take like a science class like this, you're going to become a doctor, or a lawyer, or a pharmacist. It doesn't matter. You need to be able to think critically just in life in general. Perfect example of this is I work on the site, which is why I will be gone in the second week of November. You will see me on November 8th, and then I will see you a week later. I will be flying to Maine to install some sound system at some churches. So I will do sound system installs on the side with the company. So we had went to this church to do the sound system install. And whenever we'd done it, we had a plan, had this plan mapped out. We had to run cable underneath the stage. So to do this, there was no access panels. So let this be the first lesson. If you ever build something, think, I'm probably going to have to get under this, in this, or be able to fix something on this one day. Think ahead. Critical thinking. Secondly, we had no access panels. So we had to cut holes in the drywall so we could run the cables across. And the pastor approved it before everyone starts looking at me. My God, what type of guy are you destroying your church? So we did this. Whenever we did this, we found the guys that built the stage. First, they built the stage that high. Then the second thing they did is their trash did not go in trash bags. Their trash went there on the floor because the stage was covering it, so nobody would ever know it's there. But I'm saying their trash, I mean their trash. They literally had a bag. I'm not joking. They had a bag of concrete they had used. They left the bag there. There's bags everywhere, bottles. It's like you shine a light in there and you're like, is this under the stage of a church or is it a dump? It's like awful. First off, you would never think somebody that was ever building something would do something like that. Second off, now we got a problem. because we would take a fish tape, which is a very thin, flexible piece of metal that you just run across. You can fish it up through walls and stuff, so you can fish cables. So we run it across from one end to the other, but the problem we kept running into is all the trash. Since all the trash was there, the fish tape kept getting caught up in the trash.
Did that not make it like smell horrible?
No, it wasn't nothing that would like go
Or
bad.
anything.
It was just like
They left 30 gallons of milk.
That wasn't bad.
30 years of
Copious amounts of milk. I just couldn't stop finding it. Gallon after gallon. My stepdad did that to a locker at Wyoming East.
Oh God.
So much milk.
So this, we come up with this idea. So we get the fish tape. I don't know how. Had to be the hand of God through one side, and it's about 9 feet from the other opening on the other side, and we're about 40 feet across. Got a problem. We ain't gonna be able to make this thing all the way across just by running it. So we have to come up with a way to get that fish tape to us so we can connect the cable and pull it back through. Critical thinking comes in. So we're all standing there. Mr. Hall's like, oh, I got an idea. What, bring me my hammer, bring me some speaker cable. So we did. I tied the speaker cable around my hammer, and I'm like, if I can throw it and hit the claw and pull, the claw will bring it to me. So I tried doing that, but like I said, it was about that high, so there was no way Mr. Hall was getting that thing out there. It wasn't happening. It wasn't even close. I mean, horrible idea. About 2.5 feet as far as I made it. So then I'm sitting there, and the guys that are working with me, we're all standing there, and we're like, what are we going to do? Oh my gosh, what are we going to do? Who would have thought they would have left the trash like that? We just got to think the problem. We got to work the problem. We got to fix the problem. We got to think. We got to think, and I'm like, I got an idea. Like what? I said, bring me my hammer, my electrical tape, some 2x4s, and those screws. And they were like, what? I said, yeah, bring it here, bring it here, bring it here. So I took a 2x4 and I electrical taped my hammer to the top, and I said, all right, get your drill, get your drill. And we screwed 2x4s together in increments to where I run the 2x4s through. Once it reaches the point where the fish tape was, turn it, I catch it with the claw, and then I just pull it. And I got the fish tape to me. Point of the story. I invented the Kevin Hall Hickenmaneuver.
After thousands of dollars of property damage.
So, the Kevin Hall Hickenmaneuver was assembled and deassembled in 20 minutes, but I had my fish tape. So we could run the wire.
Why'd you deassemble it? What if you needed to use
Could have
it?
got a patent on that.
Yeah, you could have done a patent.
Yeah, screw some 2x4s with some electrical tape
You'd be
and
surprised if
hammer
it
it to the end.
People buy a lot of weird stuff.
So, this is the point. How did I come up with that?
Brain.
I critically thought. I didn't allow a situation to tell me that it couldn't happen. I came up with a solution. That's what this is about. I want you to learn to think and to critically think. When I'm getting ready to say it, when I'm about to say it to you, please understand one thing. Mr. Hall loves you.
This is not a good sign.
This is never a good sign.
I
My
love
heart's
you.
about to have thousands of dollars of property damage. It doesn't always-
You have got to get to the point to where you no longer want to use Mr. Hall brain.
Oh, like that's the easy one.
You have brain in your skull. You look and say, brain, work. And you think.
I have brain rot.
Because this is what's going to happen. It doesn't matter what you're going into or what your plans are after high school. You need to be able to critically think. Just in life in general. Like work the problem. Because I'm going to be honest with you. Sometimes things in life will save you a lot of money if you just critically think. Perfect example is my cousin. My cousin's AC unit went out. So he called some guys that worked on the AC unit. The guys come out. They took a drill, took 4 screws out, removed the panel and looked and went, well, I can tell you what the problem is. What? It's a capacitor, man. They shouldn't be swelled up like that. It should look more like this. You want us to replace that? Will it make it work? I'm going to say yeah. Yeah, then replace it. Replace it. They weren't there 20 minutes. My cousin had to pay $220 when you could get the capacitor for about 35 or 40 bucks. And that's if you were buying at retail. So
There's a lot you can get for like $7. Depending on how big, but like, you can just load up on them suckers.
And you just casually know this?
I did get one for my computer when I knocked one off, and I was
it's
like,
a different capacitor.
yeah, I know, but I'm saying that.
This one big.
Yeah, I know. I'm saying depending on how big they are.
Yeah, this is about yay big round and yay.
Okay, that one would be more like $40.
Yeah.
That one would be a lot more.
But the point of the story is that he could have saved a lot of money if he would just went out with a drill and Oh, well, I think I know what the problem is. Took a picture of where the connectors were, went to an AVAC store and said, hey, you got one of these? Would have saved a lot of money. This is the point. I want you to learn to critically think. To everybody in the room that's got the whole NyQuil, I would rather take a nap than hear another lecture from Mr. Hall. Look today. Slap yourself around, wake yourself up.
I'm awake.
I think arguably the best way to critical things is to get someone that already knows what they're doing.
Drake.
This is where
Is that where this idea of FaceTime John came in at?
That was less of critically thinking and more of just praying to the only God I knew that John would have an answer.
And John had pizza, so it was helpful.
Yeah, John had pizza. No words.
And Netflix.
Alright, so here's the thing. I'm going to talk to you and we're going to work through this problem. We're going to work through it and I'm going to work through it a little fast, okay? I want you to learn and see how to get this thing. So the first thing of it is, develop a plan. You were given all this information for a reason. So the first thing you need to notice, atom. How are we going to get an atom?
Mole conversion.
Mole conversion. You must do a mole conversion.
I still never watched
In
it.
order to do the mole conversion,
You need to watch
you have to have what to start with?
Mass.
Mass. You've got area. You got units of length. You can't go from length to mass. We have to get to mass. How are you going to get it? Use a scale. A lot of y'all got 1 gram. If you got 0.9 gram, you're going to find out here at the end it really doesn't matter. Either one is fine. Because whenever you work these, I take into account there's a range that the correct answer is in. So you get 1 gram.
Yeah.
Now, with this, we got mass. So we're going to take the mass to moles, and then that moles to atoms. But here's the thing. What do you know the cost of?
the roll.
The whole roll. So here's the problem. We know the cost of the whole roll, but we don't know the cost of the sheet. You can find the amount of atoms in your sheet. So now you have to be able to draw a conclusion or relationship with the sheet and the roll. That's why you have the measurements. You have to get the relationship between these two in order to find this. So I'm going to do a metric conversion. Because look, centimeter, centimeter, meter, millimeter. Now, everybody hold on to your horses. Mr. Hall said he's going to do it fast. I do fast. Meter, meter, meter. If you want the answer, like somebody asked in first period how I did that so fast, I've been doing this a while, so that's good. Now, along with this, we're going to draw a relationship with those numbers, but that relationship is going to have to be in area. We're going to have to find out how many sheets are in the roll. Here's the thing. At this point, this is all that matters. You have to do a mole conversion, and you got to draw a relationship between the sheet and the roll. There's more than one way to skin a cat. There's more than one way to solve this problem. I'm going to show you the way I would do it. It does not mean that this is the set way. You can solve it differently.
Why skin a cat?
That's just very
Possible catch.
Like phone cat. There, is that?
Okay. So when you look at this, the relationship we're going to draw is within the area. So the area of the sheet, we get 0.0225 meters squared.
Just real quick, what's 15 squared?
225.
So,
So 22.8 times the 0.304, I get 6.9312 meters squared for the area of the roll. Now we're going to take the area of the roll, the 6.9312 meters squared, divide that by the area of the sheet, and that will give me the ratio and tell me how many sheets are in my roll. So I get 308.0533 sheets per roll. Meter squared, they cancel. So I'm left just to how many sheets are in a roll. Now, I got that information. So now I have the relationship in order to get me from the sheet to the roll. But I have to use the information of 1 gram to get me from the mass to the moles to the atoms. So in order to do this, we got to do a mole conversion. So let's set it up. So I got 1 gram of aluminum set over 1. I'm trying to get to moles of aluminum. Is it 26.98?
Yes.
Thank you. 26.98 grams of aluminum. That's the average atomic mass of aluminum. And then I'm going to use Avogadro's number. And that is atoms of aluminum over 1 mole of aluminum. Now, moles of aluminum and grams of aluminum cancel. That gets me to atoms of aluminum. So,
Is it 2.23 times 10 to the 22nd?
I think you're right. But I gotta be honest, I can't remember the numbers you just rolled off, just to be quite honest. 2.2320 times 10 to the 22nd atoms, is that what you got?
Yes.
Nice.
why you did that so fast?
Now, that's atoms, but that's the number of atoms per sheet. Beautiful job. Let go. So the number of atoms per the sheet. Now, we have to use our relationship that we got from the sheet and the roll
Divide.
per sheet. So, that's how many atoms are per sheet. I want to know how many I have atoms per roll. You do not divide, you multiply.
Of course. Dividing is just backwards multiplying.
Short answer. So,
Divide forwards.
multiply this by, oh wait, hold on, no, not 6. 308.053.
Divide backwards.
3, that gives me 6.8758 times 10 to the 24. And that's atoms of aluminum per roll. Now we know how many atoms are in the roll. Guess what else we know? We know how much the roll costs. Now, some of you all, you let me know what you think about me, Mr. Hall, and his heart.
Now we divide.
Some of you think I'm worse than the Grinch, and I need my heart to grow more than 3 sizes. Because a lot of y'all look at me like, it's a trick. That's the cost. And And I'm like, there's a whole lot of atoms in the roll, guys. I want to know the cost of one of them. And then someone looked at me and gave me this number. They were like, yeah, there you go, Mr. Hall. Yeah. That's the cost. I'm like, the atom costs more than the roll. No. Think critically. Does the answer make sense? So,
Our answer made
Yeah.
sense.
Hey,
I
you
mean,
can-
let's look at it. We take the cost, $2.29, divide that by the amount of atoms per the roll. And guess what we're going to find?
The answer.
Wow. Nothing gets by you, Andrew.
I know. I'm clicking my toes.
And here finally makes the answer.
My performance enhancing drugs are finally kicking in.
oh, there's some
We
pigs.
divided instead of
Some
multiplied.
HGH.
Guys,
Also, the Wi-Fi is back on if you use this. I know it's probably too late now, but
Oh, that's awful.
yeah.
After I do the whole.
okay.
Oops.
So, the cost of an atom of aluminum is 3.3305 times 10 to the negative 25 dollars per atom. Now, I will be honest, there was a group in here that I think you magically punched it in the calculator correctly, but you had no idea how to explain to me what you did. The reason I think that is you get a range.
That's a little bit less.
Correct
than
answer is 1.0 times 10 to the negative 25 dollars, or it goes all the way up to 6.0 times 10 to the negative 25 dollars. And the reason this happens is because of the rolls change, and some of y'all have different masses.
inflation.
That's why we give the range. So, I was very proud, and I was very excited. I was like, someone has solved it. Eureka, yes! And I looked at it, and I was like, they do not have units. Oh my God, I'm going to puke my guts.
Stop.
And then I asked, what did y'all do? Playing dumb. And they went, we really don't know. We just punch stuff in the calculator.
I had a bold conversion, just wasn't the right one.
Oh yeah, I was very impressed until I heard that we punch stuff in a calculator. It's like, no duh, Sherlock.
That was all. That would
We thought you had to.
So I'm pretty sure your group had it, but you didn't have units and you couldn't explain how you did it. You just magically used the
Well,
right number.
honestly, I could have explained it, but I just didn't want to sound like an idiot because I didn't know what
I don't feel bad. Everybody felt like it yesterday.
Yeah.
The point of this is, you're going to be wrong at times, but you got to learn how to think critically. Thinking critically is crucial. It's so important.
Why it's critical.
Exactly.
Monkeys are doing that in the Stone Age show.
Question. Any question on this?
Why is this important?
What's the price of half of an atom?
Stone.
Close.
Two.
They got divided by 2.
Yeah. One divided by 2.
What? We were so close.
What is the importance of this?
We had like everything but that.
To learn how to think critically. Andrew, I feel like I need to just
I can't tell you what we
record myself,
Let's put you in a room.
send it to you, and you play it at night while you're sleeping.
put it together.
That's a little bit creepy. How's that
I
creepy?
feel like
I don't
that's
want
the
you, like,
only
years
chance
ago.
that you're going to watch the videos and make up stuff that you need to make up. Especially, it's always fun whenever we're in here. Where'd that number come from? What are you using that for? How'd that come up?
I don't really know about that.
Hello.
Hello.
I'm just taking a tour of the building right now.
Hi, Mr. Hall.
Hey, Miss Klein, how are you
I'm
doing?
good, buddy. How are you?
Well, I'm doing very well. We just found the cost of an atom of aluminum.
A what?
Cost of an atom of aluminum.
Oh, okay. Yeah, I understand every bit of that.
Y'all want Miss Klein to take over?
That'd be a hoot. We'd be writing a paper. I'm an English teacher. This is, Mr. Hall, this is Miss Endicott.
Oh, hey.
She's gonna be the new principal next year.
Nice to meet you, Miss
We're doing some
Endicott.
learning
Nice to meet you.
stuff today. Y'all gonna love her.
I'm excited for
If they're,
sure.
if they're always this attentive, I'm impressed, Mr. Hall.
Yes.
Well, thank you.
Good to see you.
Good to see you as well. Okay, now we can move to the fun stuff. Like I said, this is going to be a pattern you guys are going to follow. Because now we're going from that problem I gave you,
More.
and we're going to start working electron configuration. So you need your periodic table.
Oh, man. Wait, the one we marked on? With the
Yeah, you can do that. So we're going to start off. That's a big O.
Orbital. Oh no.
So say my cat keeps on my periodic table and I don't have one.
I definitely have at least one periodic table in there.
I could have totally go without knowing that.
Yeah, no, it was several times. I was remembering.
All right, we're good. All right, so orbital notation. So a couple things to note when you're dealing with orbital notation. First, uses dashes. Maybe I should say underscores. I think you guys would understand if I said underscore, wouldn't you?
Yeah.
Uses underscore
Why did I need to go over?
Oh my god.
as orbital with number for energy level
Hashtag forward.
and letter for, I'm going to say block, draw that conclusion, slash the block and the, oh, what can we do?
Let's take a selfie.
I think my little brother has an underscore in his username.
World.
Tired.
Oh my gosh, I have no words now. Letter, block for block and shape. You'll learn what I'm talking about with shape later on. Don't worry about it right now.
Is it one of those accept things?
I know.
Tell me not to worry about it. That makes me want to know.
Accept!
That makes me want to know.
Accept!
That makes me.
Alright,
I'm out of
so we're going to use these underscores as orbitals with number for energy level and number for the energy level and letter for the block and shape. So, with this, it's important to know something. I want to put this in purple. For whatever reason, kids struggle with this.
Very important.
Purple?
Yes.
I can't see.
Block slash shape, along with number of orbitals.
What's an orbital?
Accept! You already know the blocks and the shapes, you just don't know them as shapes yet. It's S, P, D,
And then,
and F. Look at you! I'm so proud of you! You knew it!
it's the last one.
I take back my congratulations!
I gladly accept.
You're welcome. Okay, so the number of orbitals for S is 1. You're going to see a pattern form here. For P, it's 3. For D, 5. For F,
7.
7.
Woo!
Is that your favorite number?
Now I got a question.
No, it's going up by odds. See, I'm so
Yeah.
smart.
Odds?
1, 3, 5, 7, 9. There's no 9.
Just accept it.
I don't want it.
Okay, I've accepted it.
Why
should I? But
Why?
rebellious.
It's a whole lot better to do it this way because in years past I learned if I do the quantum numbers first, there's a whole lot of confusion and then everyone gets caught up on the confusion.
Quantum numbers?
And then they don't learn the patterns. But then if I start here with electron configurations and you're like, that's just it. It's like, yeah, that's it. We're going to keep doing this. And it's like, that's all. Like, there's no trick. I'm like, I can't give you a trick. This is it.
Okay, so like the numbers, they don't represent anything. It just goes from 1 to 7 in odd number.
Yeah, these
You said quantum number and I'm confused.
are the number of underscores.
Oh.
Quantum numbers come after this. I don't know if we'll get the quantum numbers in for Friday's quiz or not, but we'll get them. Don't you worry. Okay.
Oh yeah, you told me if you found it.
So, the number of orbitals. There's 1 for S, 3, P has 3, D has 5, 7, and there's 7 for F. Now, another piece of information to this, and I'm going to put this one in purple because it's so important, and I'm going to stress something to you right now. And I'm going to address the 4th quantum number because of how important it is, but I want to make sure you get this in your brain.
Is it 9?
Uses arrows to represent electrons. They must point in opposite direction. Because of the spin of the electron.
Electron spin.
So the 4th quantum number that we're going to discuss later on, I'll go in more depth with it later on, but it is called the spin quantum number. So the spin, their electrons spin. And the reason they do this is what are electrons? Negatively charged subatomic particles. So if we put them in the same space together, what are they going to do? They're going to want to repel. So what happens is if you take something that's electrically charged, you spin it, what happens is it builds and creates a magnetic attractive force. This magnetic attractive force is strong enough to negate and overcome the natural electrostatic repulsive force of those electrons. So, I'm going to ask you to do me a favor. We're going to work an orbital notation. Please, for the love of God, make it simple, like between 1 and 26. Someone give me an element.
8. Oxygen.
25.
Give me 115.
Oxygen is perfect. I'm not doing 115.
Why can't
Okay.
we do
So, we're going to do oxygen.
Yumpatunia?
Here's the thing. This is why I love using my method so much. And all of you that are about your field method with the whole diagonal things, this won't work for you if you don't use my method. I go on my periodic table. I find the element, oxygen. Hey! I mark it. And then I look and I go, okay. First energy level, 1. S, I'm all the way through. 2S, I'm all the way through. But then I get to 2P, but I don't go all the way through. I stop at oxygen. How far in that P block did I go? 1, 2, 3, 4. 4. Where you stop at is one that you count as well.
Okay.
So, here's the thing. We're going to use underscores. So we'll put an underscore. Below it, you put the energy level, and the shape or the block that it went through. So we went through the S, there's one S. So one S. Everyone's like freaking out, like, oh, I'm so confused. You should be confused right now. Give me about 3 of them and then let me know.
Did we go over these shapes Friday? Is that what I'm doing?
Come see me at lunch. Okay, 1S, what came after 1S? 2S, we went all the way through 2S. Here's the thing. Notice I only drew 1 dash, 1 underscore. I gotta change that terminology in my brain. For the S, look here. S. 1. I go to a P. How many underscores?
3.
So here's a P coming up. I go 2P. So it's 1, 2, 3. For congruency, put it in the middle. So these all 3 are the 2P. Go to the middle one, 2P. That's what I'm saying. Put that in the middle because it's going to look a lot smoother. If you don't, you're going to crunch everything up and you're going to get really confused really fast. Here's the thing. The 1S and the 2S is full, right? I know that. So I can go on and do this. Now, I'm going to stress to you. You can do your arrows like this. I do my arrows different. I do my arrows like this. The reason I do that is it just saves me time. Whenever we're doing a big one here in a second, you'll see it does save some actual time. So we'll do down. We'll go to 2S. Up. Down. Now we're in 2P. You didn't go all the way through 2P, so I stopped. I look and see how far I went in. I went 4, right? So I have 4 electrons. You have to remember those 3 rules we covered. The third one is the big one, Hund's rule. Remember, each orbital of the same energy level will receive 1 electron first. That's the thing. This is where this plays in at. These are all 3 orbitals of the same energy level. Every one of these are going to get an electron first before the second one will come in. So you're going to get an electron here, an electron here, and an electron here. They all receive 1 first. And we always point up to start. Then our second one, well, the last one, we got 4, right? I've put 3 in. I got a 4th one. You just start back over. So the 4th one will go right here. Does the arrow point up or point down?
Down.
Why down?
You already got one pointing up there.
Why down?
Because they got to be
They
opposite.
have to,
The spin of the electron.
yeah.
You have to represent the spin of the electron. So it has to go down. That is a proper orbital notation of oxygen.
Yeah, I'm lost.
It's okay. I expect you to be lost right now. I don't expect anybody in the room to be looking and saying, man, I'm ready to quiz on this right now.
Give it to me.
Give it to me.
So I'm going to choose one.
Kind of.
Okay? Just follow the pattern. Trust the system. Okay? Don't freak out on me yet. Alright, we got 2 minutes. We can get one done. I'm going to do phosphorus. So number 15. So like I said, on your periodic table, we're going to find phosphorus. Here's phosphorus. How far in did we go in that P block?
3.
So 3. I have 3 electrons that's going to go into that P, but which one? Notice. Where all do we go through? We go through the 1S, 2S, 2P, 3S, 3P. Oh, I stopped, and I have 3 in 3P, right?
Yeah.
So, I'm going to draw all my orbitals out, then I'll fill them. So I have the 1S, 2S, 2P, 3S, 3P. Do I draw 4S?
No.
No. Why do I not draw 4S?
You didn't go that far.
I didn't go that far.
Yeah.
Every one of them are full except for which one?
3P.
3P. So I'm going to go ahead and fill them all up. Alright, so I get to the 3P. Wait, how far in the 3P? How many? 3. So it's 1 up. Do I go over 1 or put the next one here?
Put the next one there.
Over. You go over.
Over.
Oh. Oh, yeah.
You're caught up in leaving class.
I thought you meant down.
You're alright. We will pick this up tomorrow.
Okay.
A wonderful day. So line emission spectrums pretty much break down to this. Taking the light, running it through a prism, to break it into its components. The idea, it works like our fingerprints. Alright, so this right here is what we're talking about when I'm saying a line emission spectrum. So what we'll do is we can take a light coming from a source and we'll run it through a prism and it breaks it off. Like up top here is hydrogens. So as you see here through hydrogen, these bands work as a fingerprint for that element. So you remember that light, that cathode tube I showed you yesterday with hydrogen? That's what happens. We take that light, run it through a prism, and these are the bands we'll come up with. Now the cool thing with it is these bands are at exact wavelengths. So it's literally like if I had taken everyone's thumbprint in here and compared it. Everyone's thumbprint's different, right? It's the same thing for these elements. When you're seeing this, those line emission spectrums, they all are different, and every one of them work as a thumbprint for that element. So I can take light that's coming from a planet, run it through a prism, break it apart, find these bands, and I can say, this planet has this on it, has this on it, has this on it. It's made this much, this planet has this much of this on it. This is how we're able to do this without ever sending any equipment there, without ever walking on the planet ourselves. We can determine what is there just by the light and electromagnetic radiation coming from it. I think it is pretty cool.
Can I use the bathroom real fast?
Yes, you may. I now take the hall pass. Now, I have good news. Yes.
I need the light
Ah, yes. Yes, you do. I'm so sorry. Mr. Hall has a gift. How many of you think this class is pretty difficult? Nobody raises their hand, so it's easy. Got it? Neat. Okay. Thanks, pretty hard. I want to give you something. We're getting ready to go into one of the lessons that it's a pattern. You find the pattern, you follow the pattern, it'll go well for you. To do that, you're going to need a periodic table. Why is this good? What do you get on every quiz? Well, therefore, you will have the pattern here for you. Dragon, what's scary?
Whenever they finish the test, would it be possible to look at ours?
I guess we can do that.
Because I really want to look at mine after seeing my grade.
I guess we can do that. So we're going to get into something. And the easiest way to define it is with electron configuration, is what it's called. With electron configuration, what you're going to see is this lovely pattern that if we follow the pattern, you will do great. If you do not follow the pattern, you will be in trouble. So for all the love of humanity, please pay attention, follow, and get the pattern. Trying to pull up my rules first. I want to make sure I tell you the rules right. So there are a certain set of rules that comes to doing electron configurations. So there's 3 rules. I'm going to give you the 3 rules, and then we're going to worry about the pattern. So the first one.
Excuse the interruption. I hate the body more than anything in the world, but I have senior night tonight, and I need to see these seniors in the office because I got to get the paperwork from them. Taylor Stepp, Kelly Adair, Aaliyah Dishman, Blake Good, Britton Loving, Chase Morgan, Donna Toller, Colton West, Cameron Sanders, Philip Fox, Emily Johnson.
Every single one of them are at trade school.
Alright, so the first one we're going to talk about is the off-ball principle. Okay, I know this looks like a very weird spelling, but it's named after the guy that figured it out. So off-ball principle, and in this you're going to have to accept some things for right now. I'm just going to tell you that openly. You just got to straight up accept it. Then we'll get to teach you what it is later. So if I look at you and tell you just accept it, bear with me for a moment and just accept it for a moment. So the off-ball principle states that electrons will occupy the lowest energy level possible. Thank you, sir. So this is kind of a way to look at it. Electrons are kind of lazy. So, electrons do not like going into traveling farther than what they need to. So they're going to take the lowest energy spot that's possible. You'll see what that means when it's talking about here in a second. Gracias. So the second one is the Pauli exclusion principle. This will be your favorite one. Pauli exclusion principle states no two electrons in the same atom, thank you Whitney, can have the same 4 quantum numbers. So I'm going to foreshadow a little bit. We're going to deal with the quantum numbers later, but the quantum numbers are kind of like zip codes. So 24870 is Oceania. Can Pineville have 24870? No, it's the same thing. Just like our towns have different zip codes, our cities have different zip codes. The same thing's happening here. All these electrons have to have different quantum numbers. And that's what we are focusing in on here. We're focusing in on the fact of where these electrons are at. That's what we're caring about. That's what we want to know. The last one is the one that I find kids struggle the most with. Hund's rule. Hund's rule states, and I know you don't know what this word is, but like I said, just accept it for right now. Orbitals of equal energy level will all get 1 electron first before getting the second one. So, these 3 rules combined to show you, teach you, and lead you, and guide you through doing electron configurations. So, if we're going to do electron configurations, we have to have a field order. You turned yours in. So, there's a reason I gave you the periodic table I gave you. Today, I'm going to teach you the 2 methods for getting your field order. As soon as it comes up. There we go. Now, at no point do I expect you to be able to just roll this off like I can. I've been teaching this for a couple years, so I got it. But this is all about the order in which these electrons are going to fill. This is what we're talking about. So field order. your fill order will go in this order. 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P, 5S, 4D, 5P, 6S, then it all gets freaky and weird. Because we go 6S, 4F, 5D, 6P. Then it gets freaky again.
What even is that?
It's the fill order.
What's a fuel order?
It's the order that the electrons will fill with energy levels.
Oh.
7S, 5F,
We have to memorize this?
6D, nope, 7P. You don't have to memorize it. That's why I'm giving it to you like this first, because then you get all worried that you're going to have to memorize it. I'm going to show you 2 methods of how to make sure you can get it. So I'm going to show you the first one. The first one is not my favorite. I really don't like it, but some kids do, so I still teach it. So this is all about how to find fill order. So we're going to make 4 columns, and each one of them are going to be the different shapes. So the first one is S, so we have let's do 1S, 2S, 3S, 4S, 5S, 6S, 7S. And I'll just go straight down the line. 1S to 7S. Then you get to change. We're going to go to the P, but the P's don't start at 1. The P starts at 2. So come here at 2, so it's 2P, 3P, 4P, 5P, 6P, 7P. So always remember the P will start with 2P. 2P or not 2P? That is the question. Yes. I see that this class is always like you drank half a bottle of NyQuil.
I can't go to sleep without ridiculous amounts of melatonin. I'm very sorry. I woke up this morning and I could individually feel every tooth.
Okay.
I think you got in the wrong medicine cabinet. I just said, hey, Lisa, can you give me some melatonin? And then I woke up and I was dead. I think I fought the Grim Reaper.
At least you won.
I don't know if I did.
Alright, now we're going to the D. Just like with the P, you're going to drop one. So we're going to go 3D. 3D. 4D. 5D. Now, D is different. It stops at 6D. Then we have one more. We have the S.
Figured it out. It goes 4 and 5 F and then that's it.
Yes. So 4F, 5F.
That's not horrible.
No. The key to doing this method is you have to make sure you get this lined up properly. That's why I don't like this method. Plus I got one of this periodic table and it works 1,000 times better. So now you just draw diagonal lines going through them. like this. And this is the order you have to draw the lines. So it goes through, I hit the 1S. Second line, 2S. Third line, 2P, 3S. I'm gonna slow down. I want to make sure you're getting this. Bless you.
No, that's not horrible. Because don't you just get that same order?
You're gonna get the same exact order. I want to make sure you get you have this method or you have my periodic table method.
And you said other students don't like using that method?
They don't like using this method?
I don't like this method. Some students still like it, so I still get it.
I kind of like that method.
Hey, whoa.
The other
You
method-
ain't seen my method
The
yet.
other method has to be really good.
Suck up. Where's my brother?
I'm just saying.
Kendra, did you say that?
3P,
Say that? What did you just say?
4S,
Well, the other method has to be really good. I like this one. Yeah, we sound good.
next. This is where the D starts coming in.
Don't compare me to my kinfolk.
3D, 4P, 5S. You can see we're just drawing diagonal arrows and we're following through the diagonal arrow. Then, so we go 4D, 5P, 6S. Then we'll go, bless you,
Thank you.
4F, 5D, 6P, 7S. So it's 4F, 5D, 6P, 7S. And then as I'm all sure you all can predict, 5F, 6, good deal. 5F, 6D, 7P. That is your fill order. You will see that was from my memory. This is a method to get it. This is method 1. Only thing with this, you have to make sure you can line these up right. Okay? Method 2. I bring you to the periodic table. The mighty periodic table. See how this does. I think that may work. The periodic table, I use this periodic table just for this lesson. It is made for this. But you have to understand the periodic table. So the first thing is you have to understand the rows. So there's 7 rows on the periodic table. Starts here at hydrogen. There's 1, 2, 3, 4, 5, 6, 7. For those of you who want to look and say, Mr. Hall, down there, the lanthanize, the actinize, that's 8 and 9. Well, look where these guys come in at. You see these little blocks? You get a 57 through 70. Where's that at? Hey, there's 57. There's 70. This belongs to row 6. And the same thing for the actinides. This is row 7. Now, I always enjoy this portion because you kind of feel like you've experienced prison. I know. What do you mean? I mean it because you have to know the blocks of the periodic table. The first block is the first two columns. This is the S block. Second is the P block. The P block starts at column 13. This is the P block. Third, as I'm sure you have predicted, is the D block. This is the middle of the periodic table. And then the only thing that is left is down at the bottom. Feels like solitary confinement. This is the F block. Now this is the thing you're going to see with this. If you know the blocks, you know the rows, you follow the rules, the periodic table is made for you to do this with. This is the method I like. No, man. There's only one exception to this. You have to keep one thing in mind. Helium jacks you all up. Helium actually is not here in the P block. We take helium and shove it over here in the S block. I stress that to you. Helium is in the S block. Now, it's made for you. Just look at the row. So what you're going to deal with, the row you go through, take the number, and then just put the block after it. So first row, I went to the S block. So guess what that is? 1S. Helium's over there, so it's marked out 2. Well, now that's all done for. Let's go to the second row. I'm in the second row, so it's 2S, because I went in the S block. Do I go through the D block?
Whoa.
I'm waiting. Second row, right?
Yeah.
S block.
Okay.
I went through it. That's 2S. I don't go through the D block because there's no elements here, right? But second row, what do I hit? P block, so that's, put the number first. 2P. Second row, P block. What's after that? Second row's over with now, so where do we go? 3.
I know now.
So third row, I go into the S. What is it?
3S.
It's 3S.
You just go straight across.
That's all you're doing. Nothing in the D block yet, but I hit the P block. So this is 3P.
I can see why you like that one because it's lined up already.
Fourth row,
4S.
4S. Now comes the rule. You have to remember this. For the D block, the number is equal to row minus 1. Here at the D block, to get the number that goes in front, number equals row minus 1.
So the fourth row for D would actually be 3D.
Like 3D.
It's 3D. How'd you get 3D?
4 minus 1.
The row's 4, minus 1's 3. 3D. Everybody got that?
This is easier.
All right, I'm in the 4th row, but now I'm in the P block.
So it'd still be 4.
4P. 4P. What comes after the 4th row is the 5th row, so 5S.
5S.
Now I'm in the D block. What's the rule?
4D.
It's 4.
4D, because I'm in the 5th row, row minus 1,
And then 5.
boom. 4D. What's after 4D?
5P.
5P. What comes after 5P?
6S.
6S. Now this is where it all gets freaky. And this is why I love this periodic table. It's built for you to do this. You see the gap?
Yeah.
That reminds you, hey, got to make a trip. We got to go to F block. Now, F block has a rule like D block. Number equals row
Chastity to the office.
minus 2 at the F block. So I'm at 6S. I hit here. I have to come down to the lanthanides. It's the 6th row, but I'm in the F block. So 6 minus 2, it's 4F. All the way through. Once I'm done with that, follow your numbers. There's 70. I come up here to 71. I'm back in the D block. I'm in the 6th row. What is it?
5D.
5D. Then I get to the P block and it's the 6th row and it's P, so it's 6P. Then you get to the 7th row. 7S. Oh, we got to make a trip. F block. 5F. After 5F,
6D.
6D
7P.
to 7P. That is how I use the periodic table to do my electron configurations.
I like that.
Now,
I do not like this at all.
does not matter if you like this one or if you like that one. If you like that fill order, you're just going to have to keep track of your electrons. Not a problem. You just got to make sure to keep it in mind. Any questions? Okay. I am going to try and give you your quizzes back so you can look at them. Listen to me. Your lab is Monday. Tuesday you come in. We will start working with these. I don't care which method you choose. You need to choose a method and follow it. Okay?